Hello everyone, this is the second lecture for the chapter solid state, and in this lecture we are going to study about the crystal lattice and the unit cell. First of all, let us understand what is meant by crystal lattice. In the previous lecture we have came across a term which was known as crystal, and as we know, a crystal is formed by the regular repeating three-dimensional arrangement of its constituent particles. These constituent particles can be either atoms, molecules, or ions. Constituent particles means those particles from which this crystal system has been formed. Now, if these constituent particles are removed from their position and instead of these particles we put a point, then the point is known as lattice point. These lattice points in three-dimensional arrangement form a system which is known as space lattice, also called as crystal lattice. So, a space lattice can be defined as an array of points showing how molecules, atoms, or ions are arranged at different sites in the three-dimensional space. The next point is unit cell. The unit cell is defined as the smallest repeating unit in space lattice, which when repeated over and again results in a crystal of the given substance. To understand in easier way, we can draw a comparison between the crystal and a wall which is made of bricks. Now, if we want, we can separate all the bricks of the wall, and if the bricks are put in their place again, the wall can be regenerated. So the bricks in the wall are same as unit cells in a space or crystal lattice. The figure 1.10 shows such an hypothetical unit cell. This unit cell has three edges A, B and C, which are which may or may not be mutually perpendicular, and angles between the edges alpha, beta and gamma. Thus, a unit cell is characterized by 6 parameters A, B, C and alpha, beta, gamma. Types of unit cells. There are 2 types of unit cells: primitive and centered unit cell. First type, primitive unit cells. When the constituent particles, that is atoms, molecules or ions, are present only at the vertices or corners of the unit cell, it is called primitive unit cell. The other type of unit cell is known as centered unit cell, and as the name suggests, particles are present at the center of the unit cells along with the particles at the corners. A point has to be noted that the particles are always present at the corners. Now, the centered unit cells are of 3 types. First, body-centered unit cells, or also known as BCC in short. In BCC type of cell, the constituent particles are present at its body center along with the particles at its corners. The second type is FCC, or face centered cell. Such a unit cell contains one constituent particle present at the center of each face, beside the one that are at its corners. The third one is end-centered unit cell. In such unit cells, a constituent particle is present at the center of any 2 opposite faces besides the one present at its corners. When a wide variety of crystals were studied, it was concluded that any crystal belongs to one of the 7 regular figures, and these basic regular figures are called 7 crystal systems. These crystal systems are determined by the angles between the faces and their adjoints. The 7 crystal systems are cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. A French mathematician, Brevis, in 1848 showed from geometrical considerations that there can be only 14 different ways in which similar points can be arranged in three-dimensional space. Thus, the total number of space lattice belonging to all the 7 basic crystal systems put together is only 14. And these 14 lattices are also known as Bravais lattice. The table 1.3 gives a relation between the cubic system, the axial distance or edge length, the axial angles, and the examples. And the 14 type of Bravais lattice can be seen in this particular figure. Next is number of atoms per unit cell. This is a very interesting and important topic. Let us understand it in a very simpler way. To understand it, first of all, we have to understand the contribution of particles at different points in a unit cell. Let us take a particle which is present at the vertex of a unit cell. It can be compared with a brick which is present at the corner of a room. That particular brick which is present at the corner of a room can be shared between 8 rooms, or the particle which is present at the corner of a unit cell can be present in 8 unit cells. Hence, its contribution in a particular unit cell is only 1 by 8. Similarly, if a particle is present at the face of a unit cell, then its contribution will be 1 by 2, because it can be shared between 2 unit cells only. However, if a particle is present at the body center of a unit cell, it won't be shared with any other unit cell, and hence its contribution to that unit cell in which it is present will be 1. Now consider the number of particles per unit cell 1 by 1. First of all, the primitive unit cell or the primitive cubic unit cell. As we have seen, in primitive unit cell, the particle is present only at the vertices. A cube has 8 vertices. Each vertex has contribution 1 by 8, So the number of particles will be 8 into 1 by 8, that is equal to 1. Or the primitive unit cell has contribution which is equal to 1. Similarly, next is BCC, body centered cubic unit cell. In body centered cubic unit cell, 8 particles are present at the corners. So 8 into 1 by 8, that is equal to 1 atom. Now the 1 atom is present at the body center. So the total number of atoms per unit cell is 2. One contribution for the particle at the body center, the other contribution of the particles which are present at the vertex. The next is face centered cubic unit cell FCC. In FCC, as we have seen, the particles are present at the vertices as well as center of the faces. The contribution of particle at the faces will be 1, as we have already seen, 8 into 1 by 8. Now, any cube has 6 faces. Particle at the face contributes 1 by 2. So the total contribution of particles or the atoms present at the faces will be 6 into 1 by 2, that is equal to 3. So the total number of atoms per unit cell will be 4. 3 from the face centers and 1 from the vertex. Thank you.